Section 1.1, we're going to start by talking about calculus. Surprise, right? Surprise. But it would probably be a good idea to talk about what in the world calculus really is. What are we trying to do? What's the overall goal? So the reality is calculus as a sort of idea could be described as the mathematics of change. Now, if you look up defined calculus inside of your phone, it's not going to tell you that. But that's a general idea of what we're going to be doing. We're looking at how things change and what we can do to find quantities that are changing. So these first few slides, which is all we're going to get to So all we're going to do today is going to be taking a look at these different ways that we can see how calculus is used to find something versus how pre-calculus, anything you've had before this course, would be used to find something. So to start with, if you don't have calculus, you're able to find things like the value of a point, right? You can find this value right here. If you know the x value and you have an equation or a graph, you can move it over, you can find the y value, right? What we're actually able to do with calculus is we're actually able to find the limit. Now that might not mean much to you, but it will later. It is distinctly different. It's related, but it's different than finding the actual value. This one, visually, you can see though. With pre-calculus, you're able to find the slope of a line. In fact, you probably all remember the equation. If you don't, we'll get there. We'll remind you. You can find the slope of a line. This happens inside of an algebra course is the first time you see it, maybe even pre-algebra. But what you can actually do with calculus is find the slope at a point on a curve. That's very different. There's not a formula that's the same that works like that because it's not straight. But we can do that with calculus. With pre-calculus, you can find the secant line to a curve. So secant line means a line that cuts through 2 points on your curve. And you can do that because when you do that line, it creates a line. And with a line, you can find its equation, right? Because you have 2 points. And you need 2 points to find a slope. But with calculus, you don't need 2 points. You just need one. With 1 point, you can actually find the slope, right? We just talked about that before that. And you can have another point on this line. You can create an equation of a line with calculus. With pre-calculus, you're able to find the average rate of change between 2 points. So think about that as like your average speed. You're able to find average speeds. But with calculus, you're able to find instantaneous speeds, a speed at a specific point, right? So you think about driving your car, like that's the speed that your car actually says you're going right now when you look down at your speedometer, right? You're able to do that from a theoretical standpoint, like given information, not just sitting in the car looking at the speedometer. You're able to do that with calculus. With pre-calculus, you're able to find the curvature of a circle. Circles are very specific objects. They have some very defined characteristics. But with calculus, you're able to do it for any shape, right? This curve, this random curve that seems to have, arbitrary kind of features. Any curve, we're able to do that with. This one relates back to the first one we have. You can find the height of a curve, right? The height, the location where you are in space with pre-calculus. With calculus, you can find the maximum height. So you can find the location where it's the absolute peak. It's very profitable, right? Like you want the profit to be the most if you're thinking about things in terms of a business sense. Calculus can do that. Pre-calculus can't. It's a very important feature. These next two, we won't get to this year. This is not this semester course stuff, but they are differences. You can find a tangent plane to a sphere, right? Like the plane that touches a sphere specifically, because spheres, much like circles, are very defined objects, very specific characteristics. But with calculus, you can find it to any surface. It's arbitrary, right? You don't have to have those specific features. With pre-calculus, you can find direction of motion along a line. And again, you see the arbitrariness with calculus, right? We can do it along a curve. Do you see the difference in these columns? The columns on the left are all very specific shapes, very, very concrete. They follow certain rules. And everything on the right is very arbitrary. 2 more slides, but I don't think we're going to get to both of them. We'll do this one and we'll stop. Okay? So when you don't have calculus, you can find the area of a rectangle. What is it? Base times height, or maybe you remember it as length times width, right? Yeah, you can find the area of a rectangle. But in calculus, we're actually able to find the area under an arbitrary curve, right? That top of it is not straight. It's not a line. It didn't create a rectangle or even a trapezoid for that matter, right? It doesn't do that. It's arbitrary. We will get to that one this semester. The next one's actually not in this semester. It's in Calc 2. You can find the work done by a constant force. You may have done that in physics before, right? Trig-based physics, you can do that. We can do it with a variable force in calculus, and you will if you take a Calc 2 course. In PreCalculus, you can find the center of a rectangle. It's very easy. You just measure it, right? Measure this one, where they cross. It's easy, right? Conceptually, it's easy. We can actually find the center of an arbitrary region with calculus. You can find the length of a line segment, right? This is easy. This is distance formula. You may not remember it, but this is a pre-calc concept. Somewhere around like 7th, 8th grade math, you learn how to do this. We can do it for a curve in calculus. It's all about arbitrariness. I have one more slide to show you the differences. We'll pick up there next time and finish that slide, and then we'll do a couple of examples for this section, all right?